Homework busy? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
States that in addition to its rest energy, a moving proton, P prime, has kinetic energy. This proton collides with a stationary proton, just labeled with P, and the reaction forms a stationary neutron, a stationary proton, and a stationary pion. According to the following reaction, the one shown here, the rest energy of each proton, neutron, and the pion are shown here, EP, En, and E pi for pion. The question does ask, what is the kinetic energy of the moving proton? So in this reaction, everything here is stationary except for this P prime, this moving proton, as they say. So if we're looking for kinetic energy, we know that in these types of reactions where we have moving objects, stationary objects, collisions, etc., that we have to have energy conservation, so that our initial energy has to equal our final energy. So this is before and after our reaction. So if you look at all of our energy terms, it has to equal. So on the left-hand side, the first term, the moving proton has kinetic energy. I'm calling KEP. It also has stationary energy, or sorry, rest energy, not stationary. It is stationary, but it has rest energy. That's EP, which is equivalent, of course, because every proton has the same EP, so sorry, same rest energy. And the rest energy of the stationary proton has to equal the rest energy of the neutron plus the rest energy of this proton plus the rest energy of the pion. As shown here, we note that there's one energy of the rest energy on the proton term for each side, so we can cancel that out, and we can simply solve this equation for the kinetic energy of the moving proton to be the rest energy of the neutron plus the rest energy of the pion, subtracted off the rest energy of the moving proton. And we substitute in values here. Everything has MeV as a unit, but we have 939.3 for the neutron plus the 139.6 of the pion. And we subtract off the rest energy of a proton, 938.3. Oh, my mistake. This is 939.6. That didn't seem right that they're both off by 1. So that's what caught my attention. 939.6. That makes more sense. This also to this term here is 6. I think that's right now. 939.6 for the neutron, 938.3 for the proton, and 139.6 for the neutron. All this has units of MeV. And by doing this little bit of math, we find that the kinetic energy of that moving proton is 140.9 to 4 significant digits MeV. And there you go.